Alright, so this problem was frustrating me, that we couldn't figure out the math behind it. It looked like when we looked in the answer that they were doing some sort of like voodoo math. And so I went through and I tried to look at it and I think I figured out how it works. So you get, the problem says a rumor spreads through a community of 200 people at a rate modeled by, and then they give you this equation, which is a dy over dt. So it's a derivative of y. But if you look at it, it has no t's in it, so it's all in terms of y. And y is the amount of people that know the rumor at any given time t, which you can only tell because t is here in the actual derivative form itself. But it tells you that the rumor begins with 2 people, so you know at t equals 0, at time equals 0 days is what time ends up being measured in, only 2 people know the rumor. And it wants you to find the rumor or the amount of people y after 30 days. So basically it's a long, arduous process of integrating this to be able to find a formula for y in terms of t by days. So really, when you break it down, I have the work here. When it tells you that a rumor spreads through a community of 200 people, that really tells you that no more than 200 people can know it. So that might help you eliminate some answers. And it tells you this rate, and that's just kind of the terms. So you want to find it at 30 days. The value of t is 30 days. So the first thing you have to do is you have to separate your y's and your t's. So taking this, you multiply this dt to both sides. So you're going to get rid of it on that side. So you have a dy equals that dt times that 0.2 times y times 1 minus y over 200. And then you can continue to do the math. So you divide out this y and this 1 minus y over 200. And you have a dy over y times y minus 1 over 200 equals the 2 terms you had left, 0.2 dt. So that's a pretty simple number to work with, and you have your t standing on its own. And then one of the things you can do with the math here is when you have the 1 over y over 200, you multiply all of the parts of it by 200. So the top is multiplied by 200, this is multiplied by 200, and this is multiplied by 200. So the idea is you had 1 over 1, and that's equal to 200 over 200. And then you had 1 over y over 200. Well, the 200 would go on top, and the y wouldn't have the 200 underneath of it anymore. So you can rewrite it as 200 over 200 minus y. So that's just how you separate it, and this is an explanation of the math we just looked at. Next is step 2. I numbered the steps. You integrate so you can get an equation for y, because you have all these d's, and so you need to integrate to get just a y. So I took the dy and the dt and kind of set it at the back of the integral like we do with the form of integrating. So you get the integral of 200 over y, because you had a 200 anyways over y, and then 200 minus y. So this is just a simplified form of what we had before. And then on the other side you have the integral of 0.2 dt. And you can already tell that that will integrate to 0.2t, which is just something good to have. Ooh, Pop-Tarts, sweet. So you have to integrate this by partial fractions. And so you do all of your stuff, and you know you have a positive y here and a negative y here. So on this next sheet, where you start off is you have this, 1 over y and this 1 over 200 minus y, which is the way you could have separated it out. And when you take your u and you have, once again, you just remember that you have this plus your constant c. And I just think it's great that you have that t, so I just drew little angel wings for that. You have a u value of y, and you have a du value of dy. So your balancer is just 1. You already have the dy, so you don't have to worry too much about that. That'll just be a positive natural log of the absolute value of y. And then on this side, you have 1 over 200 minus y, which you have to look at your u and your du and realize that your du for this negative y value would be a negative dy, so your balancer is negative 1. So instead of adding another natural log, you would subtract. So it's this here, and then using a rule for natural logs or any logarithm, if you're subtracting two logarithms, you can rewrite it as a single logarithm with a division bar. So this is the most simplified form to what we have. It's a natural log of the absolute value of y over 200 minus y equals our 0.2t plus c. So now we will raise e to the power of each side because of that natural log. So now we're going to get rid of the natural log to try and just get our y on its own. So e to the power of natural log of that cancels out, and so you have this. And that's equal to the other side. Now e is raised to this power. So I kind of skipped a step of math, but I rewrote it over here. So when you raise that 0.2t plus c, and that's the exponent for e, you know that when you're adding exponents, that means that you were multiplying bases before. And so you had an e to the 0.2t times an e to the c. So it's kind of like backwards math to get to that point, but it's still justifiable. So knowing that you had that, you can look at this e to the power of c. So e is a constant, and c is a constant. So e to the c is just going to be another constant, and for now you can just call it c2 because it doesn't really matter what the value is yet. You get to solve for it later. Just as long as, so you have to remember that now when I'm going to be referring to c, I might write c2 or I might write c, but I'm talking about e to the c, which is just another single number. So checkpoint, we know that this is our equation times this c2. This next step is a marker, just to kind of separate it out. This is the most important step, is you isolate that y. So you multiply that denominator you had, 200 minus y, over to the other side, and you get y equals 200 minus y times e to the 0.2t times c2. And then you can break it down. You can apply this value here to each of the terms inside of this binomial. So you have this 200 e to the 0.2t times c, and then you have a negative y with that on the inside as well. But this is going to be a problem since you have a y on the other side of your equation. So what you end up doing is, since this is just subtraction, you add this back over to the other side, and you keep this on this side. So you can see how that would just add back to this side because you had subtraction, so you added it to both sides. Next, you can pull out a y from this here, and you can simplify it. So it's just y, and then 1 plus e to the 0.2t times c, and this on the other side. So then you divide this over to this side, and you have a nice clean equation for y equals. But you still have these c constants, which is partially going to be a problem. But I have kind of two sheets of paper that go into that. Bear with me. So a y equals, that's what we had before. And you can break that into a 200, c, this is the c constant, c2, e to the 0.2t over 1, plus, and you're just separating out, because of the fraction bars, you can see here and here. You've already taken out this 200, so pretend like it's not there. But you can separate out to c to the e, over 1, plus all of this over itself. And that's what I wrote out here. You add it, and that simplifies down to 1. And this 1 over 99 I have to explain now, because using the equation we were just working with, we get to find what that c value is. But you're going to need to know that this is a way that we can simplify the equation at the end to get our final answer, which is just a page and a half away now. So step 4, use the values for c2, and you're going to solve for c2. So at time equals 0, you know that there were 2 people that knew the rumor. And so your y is now 2, and everywhere you had a t, you put in a 0. So all of these e to the power of, your number 0.2 times 0 becomes e to the 0, so it's just a 1. And since you're multiplying by c, c is just, it's 1 times c, a coefficient of 1, so you have 200c over 1 plus c. So now you do some math, and you can separate out, you can multiply out this 1 plus c to the other side, and you have the 200c on the other side. And then you can divide the c back over because you're trying to solve for c, and you have 200 on that side. Now you take that 2 out, and you divide that to the other side. So 200 divided by 2 is 100. Not extremely difficult math. And then the same thing we did to get that separation, you're going to break it. You have 1 plus c over c is like 1 over c plus c over c, which is, 1 over c plus 1. So, and that equals 100. So if you subtract this 1, you're going to get 99 is this 1 over c. So then hey, c is 1 over 99, because that's just, you're going to multiply the c over to this side and divide the 99, or however you like to think about this math. But this is going to make your c2 value is 1 over 99. So now when you look back at this equation, you're plugging in, your CE, 1 over 99, so 200, 1 over 99 for your C, and then you pull this down to the bottom. Well, you still have it here right now. You're going to pull it down to the bottom over here, and then just plus 1. So what you end up doing is you pull everything down to the bottom. That's why you have this to the negative power, and 1 is over 1, so that is also acceptable. 1 over 1, 1 over 1, and there's this 200 that you have to put back in, because we almost kind of tried to pull it out here. So it's 200 over 99e to the negative 0.2t plus 1. So now you're going to plug in 30, because the only variable you have left is t. And when, number of people who know the rumor in 30 days, so in terms of t, is going to be 200 over 99, negative 0.2, and then 30 plus 1. And since this was a calculator problem, this is the point at which we're able to use our calculator. This is the first time that a calculator actually becomes useful. So if you plug that into the calculator, you're just going to get 160.591, which is close to 161, which is the only close answer in the textbook. 200 is the maximum number of people that could have known it. You know that 199 is extremely high, but you couldn't rule it out completely. 5 and 32 are also very low. So really, after looking at this, they wouldn't expect you to know the answer to the question, in 30 seconds like you have when you actually take the test. Obviously, there's a lot of math, and this is just the condensed version. But that's the math behind the exact number of 161, and that is why the answer to number 78 is C.